So number 5 on the test review here, we're looking for the transformations of f of x equals log base 10 of x plus 2 minus 4. Transformations here, that plus 2 means it goes left 2, and that minus 4 means it goes down 4. So the domain of a logarithm is normally x's greater than 0, but you can see that this thing has been shifted left 2, and since that's the case, the domain has also been shifted left 2, so now it's going to be x, instead of being greater than 0, it's x is greater than negative 2. The range for every logarithm is the same. There's nothing you can do to change the range. It's going to be all real numbers for every logarithm every time. The equation of the asymptote, the parent function is usually x equals 0. The thing approaches the y-axis but never touches it. But since it's been shifted left 2, the equation of the asymptote now is x equals negative 2. On the next one, we've got negative 2 log base 10 of x plus 3. I see 3 transformations there. The first one, it's a vertical reflection. That 2 in front of it means it's a vertical stretch by a factor of 2. And then that plus 3 means it's gone up 3. So again, the domain of a logarithm is normally x is greater than 0, but shifting it left and right will change that domain. We haven't shifted it left or right, so the domain of this thing is the same as the parent function, x is greater than 0. The range for every logarithm, as I just mentioned, is the same. It's just all real numbers. The equation of the asymptote, you can usually steal that just directly from the domain. The parent function is right on the y-axis, x equals 0. And since we haven't shifted it left or right, which will happen inside the parentheses here, we're just going to say the equation of the asymptote is the same. It's a vertical asymptote, x equals 0. Those are 2 logarithmic functions. I want to talk about an exponential function now. H of x equals negative 3 to the power of x minus 4 minus 1. I see 1, 2, 3 transformations there. The first one's a vertical reflection because there's a negative in front there. The second one is that minus 4. That means that it's gone right 4. And also, that minus 1 at the very end there, that means it's gone down 1. So the domain for every exponential function is the same. The domain is always going to be all real numbers for every exponential function. It's the range that's going to be different. Now normally the range of the exponential function is y is greater than 0. But you'll notice that we pushed this thing down 1. So instead of being y is greater than 0, it's now going to be y is greater than negative 1. Since we shifted it down 1. Oops, wrote that backwards. Oh, I forgot one important piece though. There's also a vertical reflection. So that means if I was going to draw a really rough sketch of this thing, not only has it been shifted down 1 so that the equation of the asymptote there, y equals negative 1, but it's also been vertically reflected around that asymptote. So that means this thing kind of looks like this. So instead of going up forever, it's going down forever, which means this thing is y is less than negative 1. When in doubt, graph it on your calculator and take a look at it. I drew a really rough sketch, but if you graph it on your calculator, it's not going to be rough at all, and you're going to be able to see exactly what's going on there. Y is less than negative 1. That was number 5. I'm going to do number 6 next. And on number 6, we're listing transformations. All the transformations from 4 to the power of x minus 6 plus 7 to y equals negative 4 x minus 2 minus 1. And there are exactly 1, 2, 3 transformations here. You'll notice that That 4 does not have a negative in front of it. The second one does, which means there's been a vertical reflection there. The second thing that's happening here is that x minus 6 changed to x minus 2. Now to get from negative 6 to negative 2, you had to go right 4. So this thing has been shifted to the right 4 units. It's kind of hard to think about because those minus signs there. Actually, I had that exactly backwards. So it's left 4. And you probably make the same mistake as me if you don't draw a picture, so that's what I'm going to do. Think of it this way. Right now, at the original, this thing was at x minus 6, which means it's like right here at 6. The second one is at x minus 2, which means it's right there at right 2. So the only way to get from 6 to 2 is to go left 4. So it's counterintuitive. You got to graph it. Graph it, and you'll be able to see it. The last one's easier. It went from plus 7 to minus 1, so it went down by 8. And that's number 6. The next one I'd like to talk about is number 8, which is condensing logarithms. And the rule for condensing logarithms is pretty simple. Minus signs become division, plus signs become multiplication. So in all 4 of these, we're trying to condense them into one logarithm instead of 2. The question is, what's inside the parentheses? So in the first one, that 8 goes up in the exponent, so that's going to be x to the 8th divided by, the minus sign becomes divided, y. Here, the 3 goes into the exponent of the a and the exponent of the b. And since they are both of the same power, a to the third, b to the third, another way to write that is log parentheses a divided by b to the third power. You can take that, the 2 3s, and bring it right outside, because that 3 will distribute to the top and the bottom. That exponent will. On the bottom here, the 10 goes in the exponent of the x, plus sign becomes multiplication. The 2 goes in the exponent of the y. That just becomes log of x to the 10th power times y squared. Same thing on the next one. We've got multiplication in there. It's going to be r squared times q squared. And since they are both squared, another way to write it would be log of r times q quantity squared. You can bring that exponent on the outside. That squared will go to the r and q. So there are 2 acceptable answers there. That's number 8. I want to talk about number 14 next, which is a solving problem. Solve for x. 3 to the power of x plus 6 equals 19,683. Whenever you see a solving problem with exponentials, you know you're probably going to use a logarithm at some point. And since there's nothing in front of that 3, and there's nothing adding or subtracting it, the first thing we're going to do is go ahead and take that logarithm both sides. So log of 3 to the power of x plus 6 equals log of 19,683. The nice thing about logarithms, my favorite rule, is you can take that exponent and move it out front. But be careful when you do that. Write the exponent in parentheses so that they don't get lost along the way. And now, to get x plus 6, we're just going to divide both sides by log of 3. Log 19,683 divided by log of 3. That looks like something I can type in my calculator, so I'm going to go ahead and do that. I'm going to type in log 19,683 divided by log of 3. Oops, forgot my divide sign. And that equals exactly 9. So at this point, it's pretty simple. X plus 6 equals 9. Subtract 6 from both sides to get x equals 3 is the correct answer there. And we don't really need to plug that back in. We don't need to check for extraneous solutions, because the only time that we really are concerned about extraneous solutions is when we're dealing with quadratics or things to the fourth power, things to the sixth power. Since we didn't do any quadratics or anything like that, I'm not going to plug it back in. I'm pretty confident x equals 3 is the correct answer. Let's get through number 23 next. And it's a word problem. Let's call it an application problem, actually. A population of bacteria exposed to antibiotics is exposed to antibiotics and is decreasing by 7% per hour. If there are 100,000 bacteria at the beginning, how many hours will it take for the number of bacteria to decrease to 15,000? Well, let's set up a formula here. It's going to end at 15,000. It starts at 10,000, or 100,000, I should say. And it's decreasing by 7% per hour. If it's decreasing, then it's going to be 1 minus 7%. As a decimal, is 0.07. And that's all going to be to the t power, where t represents the number of hours it takes for it to decrease. Well, I can do this. 1 minus 0.07 is 0.93, so I'm going to change that to a 0.93. But I'm also going to divide 100,000 on both sides. So I'm going to have 15,000 divided by 100,000. That's probably just a fraction that I can simplify that to. So 15,000 divided by 100,000. Math, enter, enter. It's just 3 over 20. 0.15 is better, though. I'm going to use 0.15. So 0.15 equals 0.93 to the t power. We're trying to get that t out of the exponent. So the best way to do that, take the logarithm of both sides. Log of 0.15 equals, now I'm going to go ahead and bring that t out of the exponent and bring it out front, t log of 0.93. So I just skipped a step and I brought the t out into the coefficient. So in this last step, I'm going to get the t by itself simply by dividing by log of 0.93. And that becomes calculator work at that point. So how many hours is that? Let's type it in. Log 0.15 divided by log of 0.93. And I got about 26.14 hours. It's approximate, so I'm going to say t is approximately 26.14. Don't forget your units, hours. Now I have just enough time to do one more, so I'm going to go ahead and do number 18, which is my favorite problem. And it's just a solving problem. It says solve for x. 3 pi to the x power equals 900. Well, pi is just a number, so we can treat this like any other exponential equation. Let's divide by 3 first. You always want to take care of those coefficients before you take the log of both sides. So I'm going to divide by 3 to get pi to the x power equals 300. Divide by 3 to 900 divided by 3 is 300. Now to get that x out of the exponent, you're going to take the log of both sides. So log of pi to the x power equals log of 300. Of course, I can move that x to the front. Since it's a logarithm, that's okay. And now to get the x, I'm simply going to divide by log of pi. So log 300 divided by log of pi. Use the pi key in your calculator to do that calculation. Log 300 divided by log of pi. And your answer is x equals just about 4.983. So don't let the pi intimidate you. It's just a number, just like e. It's not a big issue.